example of graphing rationals and its inverse. So again, I try to pick unique, interesting problems for us to do, and this one is really good because of what I'm going to see here. So just like with the last problem, I want to start off by, hey, we need to factor first. So as I factor, I know the factors of -4 that add to be +3 will be x minus 4 and that'd be x plus 4 and x minus 1. And then I'll have x minus 1 on the bottom. So those cancel. So that means I have a whole. And so I have just x plus 4. You can think of it as x plus 4 over 1, or you can think of it as x plus 4. So this is a very unique graph because it's not a rational anymore. It's a line. That's a line. And I have a whole. So it's pretty unique in this one. So let's go through and look at the characteristics. So first off, starting with my horizontal asymptote. I don't have one because it's bottom, so there's none. Okay. Vertical asymptote, I go to the denominator, but there is no denominator. So I don't have any one of those. Okay. X-intercept is still, okay, for the x-intercept, we still solve the top. So if I solve the top, that would be -4. So -4, 0. My y-intercept is still constant over constant, so 0, 4. But I do have a whole this time. So we crossed out x minus 1, so x minus 1 equals 0, x will equal 1, and then I put that in, so I say 1 plus 4, so I have a whole at 1, 5. All right. So domain and range. So domain, the rule for domain is x cannot equal vertical asymptotes, so none of those, but we do have a whole, so it can't equal 1. And then range is also horizontal asymptotes in wholes. So again, no horizontal, but I definitely still have that whole. So y cannot equal 5. All right. I also made you a table of values in my calculator. You can see how I typed it in. I typed in the original so that I would get that error right there with 1 where that hole was supposed to be. And you can kind of tell by the pattern of the points, like 1, 2, 3, 4, error. That would have to be 5. But we got 5, so we're okay with that. So I don't have any asymptotes to draw this time. So I'm just going to start putting down my other characteristics. So I have an x-intercept of -4. A y-intercept of 0, 4. I have a whole of 1, 5, so 1, 5. Draw that whole, and then I can get a couple more points. I can definitely do, -1 was 3. Let's put a point there, and then I'll do 2 was 6. We'll put a point right there. And so I'll finish it up just by drawing it in. I'm going to use my drawing tool since it is just a line. Let's make it blue to match our stuff. And there's that lovely little line that we end up drawing because everything tended to cancel right there. So I'll get that in there. Perfect. Okay. So now we're ready to go in and do our inverses. Okay, so inverse again. So domain, remember, is to switch x and y's. Okay, so domain will now become a range. So y is not equal 1. Range will become domain. X is not equal to 5. Vertical and horizontal. So if horizontal is none, vertical is none. If vertical is none, horizontal is none. Right? So my x-intercept is now going to become my y-intercept. So 0, -4. My y-intercept is going to become my x-intercept, 0, +4. And my whole has to switch the ordered pair. So 5, 1. So I'll start by putting these characteristics down. And so here I go, 0, 4 is right there. And then I have -4, 0. I'm sorry, 0. Oh, I made a mistake. Hold up. Sorry, don't freak out. Let me erase that one little point. I'll just make it blue. Blue. Because when I wrote down my x-intercept, I switched it check, but when I did my y-intercept, I forgot to switch those. So let's fix that really quick right there. See how easy that was for me to do? But I caught it because I'm like, something's up. These should not look alike. So again, when I write the x-intercept, I do have to switch it. So 4, 0. So, all right, so here we go. We should have 4, 0. There we are right there. And we should have 0, negative 4. There we are right there. Our whole is at 5 and 1. And again, you can think about switching out these ordered pairs. So if you want to graph a couple more points, we could graph 6 and 2. We could graph 4, and we did 4 and 0. We could graph 3 and negative 1. And again, we could put as many points as we wanted to on that graph. Again, I'm going to use my solid line to connect it because it's just simply a line with a hole in it. I'm not happy with that one. Let's fix that, make it prettier. And then we'll come and do this side. Now, in every graph I've done with you, I've drawn in that y equals x. And think about, if you fold your paper on the line, y equals x, will we definitely see that inverse? And you still see that right through here as I draw in my line, y equals x. So if I fold on the green line, the red and the blue will be right on top of each other. So that's my last example. Hopefully that will help. A lot of your homework problems are very similar in that you don't have to cross out and simplify and then make sure you're just simply switching your x and y. Thank you, and I hope you enjoyed all my examples.